Hey everyone, thanks for joining. I just wanted to say welcome to everyone who's listening and just wanted to introduce our team here. Everyone represented here is from the smart contracts team at Horizen Labs. And today we're going to be talking about apestake.io, the ApeCoin staking platform. It's being developed on behalf of the ApeCoin DAO. And I'd like to quickly introduce our team here. We have Dom, who's our product manager, and Rodrigo, Ben, and Christian. We're all senior engineers on the team, and they've all had a heavy amount of influence on the project. So that being said, I'll just pass it over to Dom to go over some high-level product walkthroughs.
Hi, everyone. So first, for us to start off is just give you guys a little bit of an agenda of what we'll be going through. We'll just do an introduction of the project, what it means to understand staking and how it's being used in the sense of uh, ApeCoin and the ApeCoin associated NFTs. So then we'll move on to understanding how claiming mechanics work. We'll give everyone a rundown of the documentation around the smart contracts that were created and a bit of a technical overview of how things work and operate, how we integrated the smart contracts with the UI, and then we'll be giving you guys some suggestions at the end. Um, so the first thing I think is good for us to go over is just an understanding of what staking is. Many people probably are very familiar with this, but we wanted to just start with understanding that there is a difference between staking on a blockchain infrastructure platform, like something like Ethereum uses staking now, and Solana, where users would put a value of the blockchain token to gain rewards based on forging new blocks. For staking in NFT projects, they're a little different. They're basically built as a reward structure. How they commonly work is users will buy tokens or be given tokens based on a project, and they would lock them in for a certain period of time. It could be either rules set up or however long a user would like to lock up their tokens, and they would be given a reward structure for that. And sometimes you could lock an NFT associated to the tokens that you submit in order to kind of also build tokens within a project. And the main purpose for this is to really generate loyalty and belief and give people rewards who really believe in the project instead of somebody who just kind of wants to come in here, get a token, and maybe sell it. So it spurs growth and interest into a project. So moving on to how this relates to apestake.io. Basically, ApeDAO controls the treasury for ApeCoin, and they wanted to build a staking platform. And basically, the way that works is their community builds a proposal, and then they vote on it. So this platform came from two proposals, AIP 21 and AIP 22. Feel free to read that if you want a better understanding of what is going on and what the requirements are. So basically, our team, once we took on the project, we looked at these requirements and we did a lot of work to formulate that into technical requirements. And it took some work from us to kind of formulate what some of these requirements would look like inside a smart contract. And there were also some edge cases that our team had to work through with the community so that things worked in a proper fashion. And we'll go over one of those edge cases, which we think will be important for you to understand. So basically, on the staking platform, the community wanted to offer 4 different staking pools that a user could take part in. And they were comprised of the various NFT collections that Ape is a part of. So if none of you are familiar, basically there are three collections. There are the Bored Ape Yacht Club, the Mutant Ape Yacht Club, and the Kennel Ape Yacht Club. And they wanted a pool dedicated for each of these users who own these various assets. So there are 4 pools that you could participate in. The first one is just the ApeCoin pool. It does not have any requirement associated to it. You just need to hold some ApeCoin to participate. The next one would be if you are an owner of a Bored Ape, you would be able to participate in the Bored Ape Yacht Club pool. It does have a cap associated to it, so you could only, for one Bored Ape, you could associate around 10K worth of ApeCoin. And the other pools also have the same sort of technical requirements, where if you hold a mutant, it's about 2K and a cap. And the paired pool has a cap of 856 ApeCoin. The way the paired pool works is a little bit different than the other ones. You basically need to pair 2 NFTs to open up a staking position in that pool. What that does mean as well is that these pools are independent from each other. So a Bored Ape that you use in the Bored Ape Yacht Club pool could also be used to stake in the paired pool. Hope that makes sense to everybody. Pretty straightforward. So moving on, for each of the pools, the reward structure is like pretty much the same. Basically, whatever is associated to a pool, whatever rewards are associated to a pool, based on what ApeDAO funds, it works based on how many people are in a pool within any given time. So as time passes, the more people that are in a pool, the more the funds are distributed, and they're based on how much you are participating. So if in this instance, if one user is participating and say they are staking 223 ApeCoin, they will get 100% of the rewards for time block 0. And it would break down in these examples as you see here. If there were 2 people with various amounts, they would be given rewards based on how much they had in the pool at that given time. And that's basically how the reward structure works. One thing we did want to mention, which we think is pretty important here, is that one thing that is a little different from the way the AIPs structured the staking platform for ApeCoin is that they wanted it so that NFT is not locked within the contract. So what that means is your NFT sort of acts like a key to a staking position. So you don't have to lock your NFT to a staking position. You just have to prove that you're the owner in order to interact with it. So basically, what this means is that if you're an owner and you open up a position, if you're an owner of Bored Ape, this is not actual ID number 1. It's just used here for example purpose. But if you owned Bored Ape that was ID 1 and you had a staking position opened up, you could do what you wanted with this Bored Ape, and the owner would have the rights to this position. So what that means is if you were to transfer this NFT to a new owner, that new owner would now have rights to the staking position. It's not locked within the contract itself. So an important aspect to know here. One of the edge cases that our team had to work through that we think is important for us to go over is that the paired pool is a little tricky in the sense that because you're working with 2 NFTs, there is a possibility that you could sell one of them, but you still own the other one. And it wasn't explicit what to do in these situations, so we had to work with the community to come up with a solution. So basically the way this works is that if there was a case where there'd be a split pair, for instance, if Jimmy had sold Ben this kennel, what could happen is both parties could close out their staking position, which is this 100 ape, but the way it would be distributed from a rewards structure, like the owner of the board ape, or if you paired this with a mutant, would get the staked amount, which in this case example is 98 ape coin, and the owner of the kennel would get whatever rewards were accumulated up until that time. In this example, it's 2 ape coin. And I believe that's it for me. I'm going to hand it off to Ben now.
All right. Yeah, thank you, Dom. So yeah, my name's Ben, and I'm going to be showing you today some of the high-level documentation and the operations we support in the ApeCoin contract. So let me go ahead and share my screen here with you guys. Okay. So this landing page here, this is up right now. You can go look at this today at docs.apestake.io. And over here, this is really developer focused, so you can see all the information you want to see. If you want to go look at the audit reports, that's available here. If you want to go check the contract itself, it's deployed on Gurley. Your address is here. And the coins also, they're all listed here for every coin that you could want to use. And we do ask that you mint responsibly for everybody who would want to test this, but these are all available for you to use today. So next I'm going to go into sort of the read and write operations that we support. And the first one I'm going to go to here is how to read from the contract itself. Now, we have some examples here in ethers.js, and later on I'll show an actual test case that goes through these in detail so you can see how these operate. But at a high level, there's pool information where you could, for any specific pool, whether it's ApeCoin or one of the NFT pools, you can extract that with this API right here, all the way down into a specific address level. So if you want to get the specific stakes for a given address, we also support those operations. And if you don't need to get all the stakes for an address, if you're just interested in like maybe an ApeCoin pool's address, you can get that as well, the individual stakes. Lastly, and I know Dom had just touched on this, the pair pools are a little bit different because, again, we have a pair of NFT tokens there, and we do support bi-directional operations. So if you have the main pair, which would be a bored ape or mutant ape, you can find the kennel that's paired with that. And the other way as well. If you have the kennel, you can also go find your bored ape or mutant ape. So we try to be as flexible as we can to let you get to the information you need with our read contract data. Moving on, we have staking here. Staking is synonymous with depositing. So again, think of this as you're depositing an ApeCoin into either the ApeCoin pool or you're depositing ApeCoin for a given NFT. And these are going to be, again, the same categories here, ApeCoin or NFTs. Pretty straightforward. Not a lot of I guess things to call out as far as NFT differences here. So we'll just skip over this one pretty quick. Claiming is an interesting point here because claiming is really, like it says here, just sort of gathering these accrued rewards. So these do not touch the position you have. Whatever you've deposited in, this does not touch that at all. This is really just, kind of scraping, like it says, the rewards that you would have gotten over a period of time. And as the contract is set up, these rewards are distributed hourly. So that's up to each individual user how frequently they would want to claim their rewards. Lastly, we have withdrawing. Withdrawing is similar to claiming, but in this case, you are actually touching the position itself. So withdrawing does not have to be a full withdrawal. It can be partial, just like a deposit. You can add to the position up to a required limit if it's for an NFT. And we support that as well. Important to call out here, though, that if you do uncommit, and that's essentially the point where you've withdrawn all of the full staked amount that you have tied to an NFT, that NFT at that point would be considered uncommitted. So you would need to, recommit at that point. And yeah, with that, I'm going to go ahead and jump over into a test case example itself. So you can kind of see how one of these could work as a developer if you wanted to write your own tests for these. So in this scenario here, all we're going to do is we're going to fetch an ApeCoin payload. And in order to get this to work, there's a few things we have to do. So we have to have an initial deposit for a staker. We've got to move forward in time a little bit so we get some rewards generated. And then lastly, we're going to just execute this call right here to go ahead and get the ApeCoin stake from the contract and assert that the payload we want matches. So if we just kind of jump into these, you can see here that we're going to go ahead and do an initial deposit for an ApeCoin, right? Which, so in this case, we're going to deposit 10 ApeCoin. And we're going to go ahead and move forward. Looks like 2 hours. And we're going to confirm that, right? So we're going to confirm 10 ApeCoin are there. We're going to confirm that we have 2 rewards because we've moved forward 2 hours in time. We're the only ones in the pool. And we should expect 24 as basically the unclaimed rewards, the rewards we would be eligible for in 24 hours. Now this will vary depending on how many people enter the pool, but as a simple single user pool example test case, this is a decent starting point for you to kind of understand how you can deposit, move forward in time, and then assert that the amounts that we expect are correct. I'm gonna go and run this test quick, just confirm that this is still working. Okay, yeah, this one's still good. So again, these are, a nice way for other developers who might want to build their own, derivatives of the contract. They can do something similar to this to build their test cases and assert behavior that they expect. So with that, I'm going to pass it over to Rodrigo, who's going to go into a little bit deeper dive into the contract itself and explain some of the core concepts we have there at a deeper level. So with that, I'll pass it over to you, Rodrigo.
Thank you, Ben. Hi, everyone. My name is Rodrigo, and we're actually going to go a little bit deeper into the details of the internals of the contract, and also what are the externals methods that any developer can use and build on top of it. So the first thing that I think that we believe is interesting to mention is the biggest source of inspiration for the staking protocol was the SushiSwap Master Chef V2 contract. So if some of you are familiar with that, you're gonna find a familiar method that is called the update pool method. So basically, this method is one of the main ones in terms of the mechanics of the staking protocol, because this method is actually always called as the very first operation anytime anything happens, pretty much. Deposit, withdrawals, claimings, whatever, this method is the first one that happens. That being said, and there are a few differences with the SushiSwap MasterChef V2 version of the contract. One of the differences is that in MasterChef V2, the distribution of the rewards happens every time a new block is mined. Whereas in this case, the mechanics are a little bit different, and the distribution of new rewards happen only once per hour. So translate that into more technical terms. Actually, this method updates a few values for the pool that we're going to see in a bit. But what is important to know at this point is that the values are updated for the pool only once per hour. So even if this method is called, can be called, of course, multiple times within an hour across different operations, it will actually return at this level and nothing will happen. Only once per hour it will go beyond this point. The second difference with the MasterChef V2 is the rewards per hour concept. In the MasterChef V2, the rewards per hour is kind of a concept, is a constant value for each of the pools that you're managing, whereas in this case, it's a little bit different. In this case, the rewards per hour is not a constant. It's not a constant value, and this value actually changes at the same time that the time changes. So pretty much depending on the time you're in, this value will be different. So for instance, this is where we can introduce concepts as there is a pre-deposit time window where actually the contract will be deployed. You'll be able to deposit ApeCoin, but you will not accrue any rewards during that period. And then there will be a timestamp that defines the starting of the distribution time. But then again, when we're changing quarters based on the APs, different quarters means different rewards per hour. And of course, at the very end of all the staking periods, you can also have the rewards per hour will not take into will not be an important value anymore. And then from that point, there will no rewards be accrued from that point. So all of those business cases are taken into account and actually can be found in this other method that is called rewards by, and this is pretty much the method that handles everything that I just explained. And this is kind of the difference that we can see with the SushiSwap MasterShare v2 contract. Now let's talk a little bit about the pools. So the pools, a pool is just a struct, and we actually have an array of pools. So we have 4 pools, and actually each pool has a different ID. So the ApeCoin pool is ID 0, BAYC is 1, MAYC is 2, and BAKC is 3, which is the pair pool. So each pool has each pool is a struct and actually handles a few interesting values. Among those, I mean, the first one, which is the staked amount. So pretty much this is the total staked amount that a given pool has at any point in time. It also handles the last time where the timestamp, the last timestamp hour, which is like a whole hour, where a reward was distributed. So this is a similar concept as in the MasterShare v2 contract, where a last rewarded block is handled, but in this case, it's just a time value. And there is this value that is the same one, which represents actually the accumulated rewards per share. Just to sum up a little bit what this means. So this is, if we go back to the update pool method, actually, in this method, there are actually 3 values that get updated once per hour. Let's just focus on these 2 ones. So the accumulated rewards per share, actually, let's first disregard the accumulated part of the term. So what is the rewards per share? So it is the amount of ApeCoin you can get as rewards for 1 ApeCoin you are staking in a given pool. And the accumulated part comes because you're actually accruing this value, summing this value every time once per hour. So this value is always increasing over time, and this is like the main value that we're going to use for calculations of the rewards. Similarly, once per hour, we will actually update this value with the next whole hour every time the reward, a new reward gets distributed. Finally, the other key concept in the pool struct is the time ranges. So this is not something necessarily needed to understand externally for devs building on top of this, but it is important to note that in this case, a time range for the business case actually represents a quarter. So a time range is just a starting time timestamp hour. Again, this will be a whole hour, so pretty much meaning that the minutes and seconds for this timestamp will always be 0. It also represents an end timestamp hour. It represents a rewards per hour that can change, and a cap per position, which is the concept that we're bringing from the NFT pools, where pretty much there is a cap for each position that is the maximum of ApeCoins that can be staked for that pool. So now that we saw the key concepts of this, let's actually get to the external methods that are available for developers, and actually that the UI, of course, is using them to actually build the whole platform. So before starting this, actually, we do, as I mentioned before, we have 4 different pools. But across those 4 different pools, there are actually 3 different types. The BAYC pool and the MAYC pool, of course, they're different. They're handling different assets, different tokens, different caps. But in terms of mechanics, they work exactly the same. You want to commit an item, you want to commit an NFT. You have a maximum Ape coins that you can stake. Of course, they are different for the 2 of them. You need to show ownership when you deposit, and so on. So pretty much the mechanics for those 2 are exactly the same. Then let's start actually with the ApeCoin pool. So for the ApeCoin pool, we have, for deposit, we have 2 different methods. We have deposit ApeCoin pool and we have deposit self ApeCoin. What is the difference? The difference is that deposit self ApeCoin actually deposit whatever the amount you specify in the input to the caller address that is calling this method. Whereas the deposit ApeCoin does exactly the same thing, but the difference is that you are entitled to actually choose an address recipient if you want to deposit the ApeCoin. For instance, a use case could be you have your ApeCoin behind a different wallet or a safe, and you want to deposit to a position that already has some stake. So you could use this one. So that is the deposit ApeCoin. There is a minimum deposit of 1 ApeCoin, and that's all the restrictions in this case. There is no max. Yeah. So now let's go to the deposit BAYC and MAYC. As I mentioned, they are exactly following the same mechanics, and as you can see here, actually internally they're actually calling the same method. The only difference, of course, is that the pool ID is different. So in this case, there's a little bit more business logic involved. So for this case, actually, sorry, before getting into this, let me show the input params. So for the deposit BAYC and MAYC, it is expecting a struct, an array of structs. And this struct actually has a token ID and an amount. So how can we interpret this? Actually, this array of structs, and one struct represents the token ID, so the BAYC ID or MAYC ID we want to commit, and also the amount of ApeCoin we want to commit with this particular NFT. And of course, it is an array because we can commit multiple NFTs within the same transaction. Same goes for the deposit MAYC. So to get a little bit more into details of the business use case, and it's actually important to notice at this point that we don't have a commit method. We only have a deposit method that can also act as a commit method. So how does that work? Well, actually, if the NFT that you're willing to commit has unstaked amount already, it means that it was already committed, because committing is the act of attributing ApeCoin to a particular NFT. And in that case, any address can deposit ApeCoins for that particular NFT. So not only the owner. But if the staked amount for that particular NFT is actually 0, meaning that the NFT is not committed, then you need to show proof of ownership, which is pretty much this part. So the first time the deposit method is called for the NFT, or if it's 0, it was already used, let's say, then you need to show ownership, and that translates into the committing act. Otherwise, for later cases, it's just the deposit, as said before. And in this case, it only, like I said, it will deposit, and it shows a little bit of requirements, which pretty much it has to deposit minimum 1, and then here it's pretty much checking that it doesn't exceed the cap for that particular NFT that we know that are different for BAYC and MAYC. Then we have the deposit for the pair. So here it's a little bit more complex. So this method actually expects 2 arrays depending of the pair you're handling with. So the first input is actually an array of pair NFT with amount struct. So I'm going to show this in a bit. But the important thing here is that the first argument is actually for BAYC doc pairs, and then the second argument is for MAYC doc pairs. Of course, if you're only willing to commit one type of the pairs, you can just pass an empty array for one or the other of the arguments. So what is the struct? The struct is actually expecting 3 values. It expects the main token ID. In this case, main refers to either BAYC or MAYC. So this is the token ID of that you want to pair in the pair with. This is the BAKC token ID, and again, this is the amount you want to commit with this pair of NFTs. So similar to the deposit BAYC, MAYC, this method actually also acts as the commit method when the staked amount is 0. So to go a little bit down here, without getting too much into the details, but pretty much if the staked amount is 0, meaning it's not committed, there is a bunch of checks and a bunch of structure updated, and otherwise we want to check that the IDs that are passed to the methods are actually committed, and in that case you can go through and actually deposit that. Again, similar to the BAYC, MAYC, there is a cap, of course, for the pair, and there is a minimum of 1. So now we go through all the deposit methods. Let's go to the next section, which is the claim type of functions. So in this, the type, well, I mean, we're just claiming the rewards for each of the different pools. So for the Ape coin, similar situation. We have 2 different types. So we have one where you can specify the recipient where your rewards are going to, or you can just claim and the rewards will go to your caller address for this method. Of course, here the position is checked with the message sender. So the caller address, it's gonna you need to show ownership of that position. So for the BAYC and MAYC case, well, similar here, we have 2 different versions for the 2 NFT types. So we have the self type of method, again, where you don't specify any recipient. And then to get a little bit more into the details, remember, like I said, the mechanics of those two pools are exactly the same. It's just the pool ID that changes. But pretty much how it works here is that, of course, since you're claiming the rewards, you need to show ownership of the token ID. So whoever is calling this for their NFT needs to make sure that the address they're calling this method from is the address holding the NFT that is committed. And then finally, we have the withdraw methods. So in this case, let's start with the ApeCoin pool. Again, same, we have 2 versions as before, with the recipient and without. The important thing here to note is that there is a condition. So similar to deposit and commit, we don't have the uncommit method explicitly, but we have a withdraw where, depending on some conditions, that will also become an uncommit. specifically for the ApeCoin pool, there's no on-commit. That being said, when you're withdrawing the ApeCoin the ApeCoin, if the amount we want to withdraw from our position in the ApeCoin pool is exactly the total amount that is staked, then actually it's also triggering the rewards. So you're actually going to withdraw the full amount of your staked position, but also the rewards amount, like in here. So how is what is expected from this method? Sorry, yes, just the amount and the recipient. Then let's go to the withdraw BAYC. Well, same. We have 2 methods for BAYC, MAYC, same as mentioned before. The mechanics are exactly the same. And we have 2 versions with the recipient and without. So what are the? So here we also have an array of this struct that is called single NFT. And what is it? Well, it's expecting again the token ID that is associated to the NFT you want to withdraw ApeCoin from, and the amount you want to withdraw. So now we can talk about the on-commit use case. So actually, to uncommit the NFT for, let's say, a BAYC position, the amount attribute that we just saw need to be equal to the full amount that is staked. In that case, this will actually be equal to the uncommit action. And of course, either if it's uncommit or not, you need to show ownership of the ID for both of the use cases. Finally, we have the withdraw for the pair pool. Yes, the withdraw for BAKC, sorry. So similar to the deposit for BAKC, this method is expecting 2 different arrays. So the first array symbolizes the pairs where there's a BAYC involved, BAYC and BAKC. Second argument is for MAYC and BAKC pairs. So what is this struct that is expected? Well, the struct has 3 values. Same. We have a main token ID, which either will symbolize the ID of the BAYC or MAYC, depending which kind of pair we're dealing with. Then it expects the BAKC ID and then the amount we want to withdraw from that pair. And this method, again, if the amount specified for the given pair is the full staked amount, this will also trigger a claim rewards, and then this method will actually represent the on-commit for that particular pair. And then again, to get a little bit more into the details of this method, we have a bunch of conditions that we're checking. We're checking that the IDs are paired, effectively paired, the ones that are passed. We're checking ownership, and of course we're dealing with the case where the pair is split, and then we're just triggering the on-commit if the position. The staked amount of the position is equal to the amount. I hope this was helpful, and I hope you enjoy building anything on top of this contract. So now I'm going to pass this over to Christian, who's going to tell you more about the UI.
Yeah, thanks, Rodrigo. Yeah, so I'm going to share my screen, and I'm hoping this part of the presentation will kind of bring everything together, the smart contracts with the UI. So I'm going to walk you through our user interface and how it interacts with the smart contracts, and which user interactions trigger which smart contract function. So at a very high level, this is a React application. We also use Next.js. And for majority of the smart contract interactions, we use a library called UsedApp. If you're interested, just do a quick Google for their documentation. They have a lot of guides and examples and things like that. So I'm actually gonna also pull up the documentation that Ben had walked through, and just sort of almost like walk through like the user journey, if you will, of like a normal flow. So when the page loads, in order to pre-fill all the information for all the pools, we call the get all stakes function, and we populate the wallet address with the address of the wallet that the user has connected. The used app library exposes a lot of hooks and APIs to sort of extract that information. So once we have a wallet address from the user, then we sort of consider the user to be signed in, and we get all their stakes. We sort of get all the information for all the pools at once and render the page that way. Also a part of this is the BAKC to main function that Ben mentioned, where when the user has a kennel that it is paired to another NFT, we use this function to extract that information, to get the image of the other NFT that it's paired with. In this case, this NFT isn't paired with anything, so that is the other contract function that we use, sort of on page load, or either after the user has connected their wallet. And then for the staking and for pretty much all the actions, right? We have a lot of reusable forms for each of the pools, right? So when I have a staking position and I click manage here, I'm presented with 3 forms to deposit, to claim, and to withdraw, and obviously those are functions that we've explained throughout this presentation, and then really each of those correspond to a smart contract function. All right, so the first one that I'll do is is for ApeCoin. Actually, one other thing to mention first is the approval, right? So it is sort of a requirement for the user to approve the staking contract before they have any sort of interactions with the smart contract. So one of the first things that we do when they actually go to take an action is to check their approval, and if if their allowance is less than the amount that they are either trying to deposit or withdraw, etc., then we present them with a modal, and on click on confirm, we call this approve function with their address, and the approval amount we just sort of pre-fill with like a huge amount, so they are good to go after that. So if the user wants to stake in the ApeCoin pool, we call the deposit help ApeCoin function. So say I want to add to my position, I want to add another 10 ApeCoin to this position. I am presented with this modal, and once I confirm the transaction, really at a high level, what our front end code is doing is pretty much on submit. We check the pool ID that the pool is on, and again, this is all like in a reusable form, right? So I'll go to the next pool after this example, and it's sort of like rinse and repeat, right? So actually, let me zoom in a little bit. It's so hard to see. Yeah. So if the pool ID is ApeCoin, then all we need to do is call deposit with the amount that they are that they've entered. And for a majority of these actions on the forms, all we call is the deposit self, the withdraw self, right? The UI here doesn't really support depositing for somebody else. It's really all for managing their own positions, right? So, and if it's a BAYC, then we pass in the array of just one NFT object in this case. Like Rodrigo mentioned, we can do multiple at once, but again, the UI doesn't really have that design. So all we pass in is an array of one object. Actually, let me bring up those pools too. So this operation was successful. So my positions are updated, and really, like if you notice, like I said, these three forms are reusable components. We have them essentially all throughout the application, and also for this pool as well, for the mutant ape, and as well as the kennel. So if I wanted to deposit more into actually, I'm actually going to do a withdraw in this case. So Rodrigo mentioned that you can either withdraw a specific amount or withdraw your whole position. So if I withdraw all here, what's also going to happen is it's going to trigger a claim rewards. So we should see my deposit. I won't have a position in this anymore, and I won't have any claim rewards. And again, this you can imagine. Instead of the deposit function here, it's the withdraw function, and it's pretty straightforward. Like we know the pool ID just based on what on where the user is at that time, and we know the different arguments that we have to pass to the different functions. And again, for the Kennel Club, actually, I'll go to that next. Right. So I've withdrawn my position here, and I don't have any unclaimed rewards. So for the kennel, it's more or less the same concept, right? The arguments are different just based on which pool ID I'm on. So Rodrigo mentioned, like, if we have a kennel and we are pairing it with a Bored Ape, then for the deposit function or really for any of the functions, the sort of opposite NFT pool, we just pass an empty array to the function. We've gone through each of these. Actually want to also just mention the search functionality. So I mentioned when reading from the contract, and specifically when reading the user's staking position, we use the wallet address that the user has connected. But also in the application, we have a search functionality where you can search by address, and instead of in this case passing the address of the user's wallet, we would pass the wallet here in the search term. So actually, I think I have another wallet address I can use. So like if I search for this address, when we do the search, instead of getting instead of passing my own wallet address into get all stakes, we pass the search term into get all stakes. So that's essentially it for the user interface. I hope this kind of provide you with some information on how we interact with the contract. With that, I'll pass it to Lou.
Thanks, Christian. So to wrap everything up, I think we'll look at a few suggestions of what could be next steps for you guys. So as mentioned in some of the demos here, our user interface doesn't really support batch actions. For example, like a batch claim where you do claims for all of your positions at once, batch commits, batch withdrawals, those types of things. So some sort of utility around that concept could be a good one. A second might be some form of auto compounding tool. So right now, as you can tell, it is a manual process to go and claim your rewards, for example. But there might be a use case for someone who's looking for some automation around being able to claim and then restake their claimed rewards automatically, perhaps on a schedule, something to that effect. So there's something that could be thought about. Next could be some form of indexer or analytics tool that could fetch and kind of log the events that are coming out of the contract and perhaps create some sort of visualizations around staking activity, users committing, withdrawing, that type of thing. And lastly, and what some of you might find the most interesting is the concept of being able to build like a secondary smart contract platform on top of ours. And essentially, really the minimum required requirements, more or less, for interacting with our smart contract are to have an Ethereum account that has a balance of some sort of ApeCoin and optionally some ownership of some NFTs that are compatible with our contract. So really, presumably, you could think up any type of secondary platform that also has the custody of one of these two things, and that contract could interact with ours in some way. So it could be a game, could be a secondary staking platform, a lending platform, anything to that effect. So those are some ideas. Hopefully it gets the creative juices flowing, and we hope this was a useful demonstration for you guys. Feel free to reach out to us, and we'd be happy to try to answer any questions in the future. So thanks again for joining, and see you guys later.
Bye, guys.
See y'all.
Thank you.